This is our second lesson on integration. This time we're going to use a more formal approach. We're going to use the method of integration by substitution. What we do with this method is use given substitutions to calculate indefinite integrals. As I said, it's more of a formal method than our integration by inspection that we did last lesson. It's used to integrate complex looking functions. In fact, it's one of the main ways that we integrate complicated functions. We do this by choosing part of the integral which we replace with usually a u. We make the substitution. We then try and change everything we're integrating so that it's in terms of u, so we can then integrate with respect to u, and quite often we end up at the end returning our x values by substituting back in. In exam questions we'll always be told what expression to use for u, so what we need to substitute. Okay, let's have a go at this example. Right, looking at this example, the first thing that I would do is write out the integral again, but immediately putting in our u. So we've been told here that we're letting u be 5x plus 2. That's the bit in brackets which is cubed. So I'm going to now write u instead of the 5x plus 2 cubed. We've still got dx there, so I'm going to put that in. We can't integrate this yet because of the dx. We need to be integrating u cubed with respect to u. So in order to overcome this, and we always do this with this technique, we differentiate the u with respect to x and we will get 5. We then rearrange this, so if we multiply by dx to leave du here, we get 5 dx on the right hand side. We want to substitute the dx, so we make that the subject and it equals du over 5. We can then place this back in here, so our integral now becomes u cubed du over 5. So in other words, we're integrating 1/5 u cubed with respect to u, which we can do. U cubed goes to u to the power of 4 over 4, so we get 1 over 5 times 4, 20. And we can then replace our x term back in. And don't forget, it's an indefinite integral, so we'll add a plus c, a constant of integration. Okay, let's try another one. This one looks a bit more complicated. Again, we're given the substitution that we need to use. So we're going to let u be 2x squared minus 5. Again, the part inside the bracket, the inner function if you like. So I'm now going to write out the integral again with our u replacing the bit in brackets. And we've got a slightly bigger problem here. We've got an x term as well as the dx. But we know we've got to differentiate the u part with respect to x, which gives us 4x. We know we need to replace the dx. So if we make dx a subject, we get du over 4x. So let's place that in there. and see what happens. We replace the dx with du over 4x, and maybe you can see this now. We have an x here in the denominator and an x here in the numerator. Perhaps if we write this out as a fraction, it's a bit more obvious what's going on. So that's what we're integrating. We can cancel our x's. So we're integrating u to the power of 5 over 4 with respect to u, which equals, well, this goes to raise the power to 6, and instead of a quarter, we've now got 4 times 6, 1 over 24, u to the 6 plus c, and if we put our substitution back, that's what we've got. Okay, so let's have a little look at the method. We substitute u into the integral. We differentiate the equation that links u and x, and we always do this. We rearrange the equation to make dx a subject and substitute into the integral to replace the dx part. We then simplify, integrate with respect to u, and change the answer back in terms of x. Well, the step 5 was covered up there. We left a blank there. Well, there's a reason for that, as we're about to find out. So here, if we follow our usual process, we're going to write out the integral, including the substitution. So the bracketed bit is substituted for u to the power of 4, and it's dx. We then do what we always do. We differentiate the substitution part, the u with respect to x, and we get minus 2. And hopefully by now we can do these fairly quickly. We then rewrite the integral. We've got x u to the 4 over minus 2 du. We've still got an x here. So now we need another step to get rid of the x. And to do that, we rearrange our u equals 1 minus 2x. We get u minus 1 equals minus 2x. So u minus 1 over 2 equals minus x. Now we could turn this to plus x by simply changing the sign of what's on the left hand side, but actually, as we've got this minus 2 and this x here, we could rewrite that like that, and we may as well just substitute the whole minus x part. So minus x changes to this. Because that's over 2, we could flip that and times it by a half, couldn't we? So we would get that. Multiply it out and you get u to the 5 minus u to the 4 over 4 du, and that's what we're integrating. So we're integrating u to the 5 minus u to the 4 all over 4 with respect to u. We get, well, this bit becomes u to the 6 over 6, so over 24, 6 times 4, minus u to the 5 over 20, and then plus c. And of course, then at the end, we can replace our 1 minus 2x for these terms. So we'll put it down here. We get 1 minus 2x to the 6, and we'll put 1 over 24 in front of that, minus 1 over 20, 1 minus 2x to the 5 plus c. So we can now uncover our fifth step, which is if there are still any remaining x's, rearrange the equation that links u and x to make x a subject and substitute in. So we now have our complete step-by-step guide to integration by substitution.